Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking, said I've been technically speaking, China white.
Okay, cool. So spanning tree protocol. So let's talk about, so this section 2.5, we're just describing the need for basic operations of rapid, PVST. We'll get into that, but it's just spanning tree and different versions of spanning tree. We're just describing the need for it, okay? So we really won't be configuring anything, but we will be like verifying on the switch what spanning tree looks like from the switch perspective, okay? So let's go into spanning tree. I have a nice little blog that I wrote, so let's go in. Spanning tree. So redundant links between switches. As you can see here, we have links, these links between switches. They're redundant links and they can be helpful. What is redundant, right? So redundant means that, if something fails, if one path fails, another one will come through, right? We'll have an alternative path. So just in case something fails, we have, some other type of way we can still, route traffic, right? Now, even though those are great that we have those redundant links can cause problems. And those problems are specified here: broadcast storms, endless loops, duplicate frames, and a faulty CAM table, which is just faulty MAC table, right? So when you look at it, and I mean, you could just really look at this diagram right here, you will see that there can sometimes be some type of like I'm gonna say an endless loop, because that's kind of what we can kind of, go off of it as in, real life example. So if I send something, let's say you have, another link here to switch C to switch B. If switch A sends something without a spanning tree protocol, which is helping these redundant links, what will happen is switch A will literally send data to switch B, and switch B will literally send it to everyone that is connected to, okay? So if switch B was to send something to switch A, again, switch A is gonna send it to whoever's connected to switch A, right? So spanning tree protocol says, no, don't do that. Let's have some type of intelligence to figure out what's going on so other links can be backups and not active links, okay? So let me see down here, I guess with the 10 megabits is the speed. Let me see if a switch spins frame, every switch on the network will get it. Not only will each switch on the frame get it, each one will send an echo or a reply to a sender. So it's just, that's where the broadcast storms and duplicate frames come in, because not only are they going to send it to every switch is connected to, each switch that received that frame or that piece of data is going to send some type of echo or some type of reply. So that means that every device that gets sent some data is going to reply back. So again, imagine all that's happening. And again, that's a duplicate frames, because we've already sent it. Switch C already confirmed this data, so we don't need it from switch B, but switch B is still going to send it, which switch D is going to send something because it's, attached to switch B, and it's going to try to send it to switch A, which is going to go through switch C. Like, it's just so much. And it's just like, wow, we need to organize this data, and we need to not allow our switches to be overloaded in this, because that's just one message. Imagine if it's a million users sending a million messages, like your switches are going to go down. They're going to be overloaded. They're going to just be like, I don't know what's going on. They're going to go haywire, and you're just going to have broken switches, right? So to go ahead and clear up all of this, we have spanning tree, right? Now, scrolling down, I just gave you a little definitions of what these are, right? Broadcast storms. If multiple broadcasts are sent out, each of them will endlessly be sent to every host on the network. thereby causing what is known as a broadcast storm. Okay. Endless loop, similar to what happens in a broadcast storm. However, it entails a unicast message destined to a host that is not on the network. Duplicate frames, sending out frames out multiple interfaces where the destination will receive it multiple times, right? So again, if switch A is sending out something, it needs the intelligence to know, okay, should I send it to B or C? Don't just send it to both, because then both is going to send you something. And not only both is going to send you something, whatever they're connected to you is going to send you something, you know? So all of this is happening. So we need spanning tree to cut all that off and say, hey, here's some intelligence. You know, this is who you're going to send it to. And if this go down, this is who you send it to, right? So another like a better GPS system. Okay. So DEC, Digital Equipment Corporation, created a protocol called Spanning Tree Protocol to prevent broadcast storms and layer 2 loops by logically blocking redundant links. This is a, maybe not, I'm going to say spanning tree right there. That's, you should write that down, put it in your brain, whatever. You should put it on a flashcard or something. On the exam, and even in interview questions, they're definitely going to ask you, so what is spanning tree for? Okay, like what's the purpose of spanning tree? To prevent layer 2 loops by logically blocking redundant links. That's all it is. And then they're going to be like, oh, okay, and move it on along. Now, they may ask you some more stuff, but as far as, you know, a basic spanning tree question, this is what they're going to ask you, and this is the best answer. What is spanning tree? Right? Prevents layer 2 loops by logically blocking redundant links. I can't beat that in your head enough. Okay. All right. Now on to the standards. Now the IEEE has a standard, of course, and the standard is 802.1d. That's spanning tree. 802.1d. That is exam question. You should definitely know that. As far as like on an interview, they may quiz you, you know, if you get it right, great. If you don't, they may look at you like, you might want to brush up, but that wouldn't stop you because again, all this can be looked up. Like it's honestly not too crazy to have everything memorized in your head for interviews and stuff. You can always blame it on, oh, I'm nervous or whatever, but exam folks, 802.1d, okay? Spanning tree. So when spanning tree is applied to a looped LAN topology, all segments will be reachable by any open ports that would create a traffic loop are blocked. So again, it's just giving intelligence to the switch to say, hey, this is these are the ports you're going to send data through. These are the ports that are backup. So in case these go down, here's some backup, right? Or these ones you do not send data through. These are the ports you don't send data through. Right? It's just intelligence to tell the switch how to switch traffic. Okay. Now, there's some common terms associated with spanning tree that is very vital and you must definitely remember, specifically for my exam folks. Okay. So spanning tree, we have bridge ID. This is a unique identification number of each switch on the network. Okay. It consists of the bridge priority and the base MAC address of the switch. Okay, the bridge priority, the default bridge priority of a Cisco switch is this number, 32768. I think for my exam folks, you need to remember that. The default bridge priority of a switch is this. Okay, actually, let me see. This is configurable between, I mean, you really should know this whole definition, but honestly, as long as you understand this, what is a bridge ID? It's a number. It's a unique identification number for each switch on the network. Each switch on the network has a bridge ID, and it's made up of a priority number and the MAC address of that switch. Priority number and a MAC address of the switch. Let me see. Maybe can I show you guys? Oh yes, I can. Boom. Switch priority. This is the priority. MAC address. This is the MAC address, okay? That together creates the bridge ID, the BID. Okay, you see here? BID equals switch one. This is switch one, right? Priority plus MAC, priority plus MAC. You know what? Let's just go into it right now. Let's go into that. Let me show y'all this. Pull it up here. Let's look into this switch. And I don't think I know the spanning tree. Show STP. Show, maybe I have to actually type out spanning tree. Show, it don't say. Let's do some looking up here. Let's exit out of that. Let's do that. Let's do STP commands. So you guys can see the bridge ID and priority together. Let's do maybe this one. I probably should choose Cisco because Cisco commands are different from everyone else. Cisco just likes to be different, so that's probably why. Oh, lab, let's do lab. I think over here in the lab, there we go. So spanning tree. Let's just say show spanning tree. Let's just see what that output is. Let's come here and let's do show spanning. Is it dash tree? No, it is. Okay, so let's blow it up. So y'all should know these commands. I know I don't know it like that, but I don't really work on these switches in this job. So, okay, cool. So show spanning tree. As you can see, spanning tree is on what? VLAN 1, okay? Defaulted for protocols like spanning tree. Spanning tree enabled protocol IEEE. So that's the 802.1d. Root ID. Oh, let's go. We ain't talked about that yet. Bridge ID. Priority plus the MAC address. So you see the priority? That's the priority. And you see this is the default priority that's going to be defaulted. So you can change it if you want. And we'll talk about why we would want to change it and why we wouldn't want to change it. But just know that the bridge ID is the priority plus the address. Okay. That's the identification of this switch on the spanning tree network. Okay. All right. So now you guys can see, you guys saw that. That was kind of a visual. So you know, boom, bridge ID. What else? We have the root bridge, right? All switches in the network elect the root of the tree. Okay. So root bridge, let's come in. Where are we at? Let's come in here. Maybe if it allows me. Okay. So a root bridge, spanning tree. All these terms sound like a tree, right? We have something root, we have the bridge, we have a tree, we have these leaves. So all it's saying is that one switch will be like the delegator of where all the data will flow in this layer 2 network, right? This root bridge, right, which is the designated switch, is going to say, hey, this is whose ports are blocked. This is whose ports are going to be designated or alternative. This is the, you know what I'm saying, this is the root port. Root ports are just ports that, you know, are actively going to send the data through. So the root bridge is the actual switch that says, hey, this is how we are going to switch data from my perspective. Who gets elected root bridge? I mean, how do they get elected the root bridge? By having some type of election, right? Now they do this all their own. There's nothing that you configure, right? This is automatic on the switches. You just have to know how it works behind the scenes, because you'll never configure this. But you do not need to know how it works in case something happens. You know, like, oh, okay, this is why the data, the network is slow, because somebody changed the bridge ID for spanning tree to another switch, because they wanted that switch to be the root bridge, and it messed everything up, right? Because that's sometimes what happens, right? Especially with CEOs, they, you know, feel entitled to just start plugging things in and saying that, hey, you know, this is what I'm going to do. And it's like, well, this is not good for the whole environment. So yeah, that's usually, or maybe even a newbie come in and, you know, connect something, or if the ISP come in and connect something and messes up the whole spanning tree, the whole root bridge and bridge, the root bridge and bridge ID, then you would have to change things to accommodate, right? So again, you're not configuring this, you're just seeing how this works. So we know the bridge ID is just an ID for every switch on the network, because we're still in layer 2. We haven't got to routers yet. So in the enterprise, we got thousands of switches, right? Sometimes millions, depending how big you are. So we got thousands of switches, hundreds of thousands of switches. And those switches have a unique number. And that unique number consists of the priority and the MAC address. Priority is defaulted, so you can change it if you want. And as you can see, you can change it to these increments. We're not going to go into that, but it consists of those two. Now, with all these switches, one of these switches is a root bridge, right? And all of the switches will elect the root bridge. Will say, hey, I think that from your perspective, you should tell us what to do. So the root bridge is going to say, cool. How is it elected? I can see right here, the switch with the lowest bridge ID wins the election. Switches that do not become the bridge ID, the root bridge, are called non-root bridges. Okay, so how do a switch in the network become a root bridge? Well, it has the lowest bid, the lowest bridge ID. What is the bridge ID? It's the switch and the priority right here, defaulted. If you didn't change it, this is what it is. And the MAC ID. Right, so of course the lowest, and MAC IDs is in hexadecimal, so you can just imagine going through that. Okay, again, the switch is doing this automatically. This is pre-configured when you get it out the box. All right, so boom, now they have their leader. So everyone has their identification, and now the lowest identification wins what's going on. Okay, now a little fun fact that I've learned on my first contract is MAC addresses are the lowest MAC address, like MAC addresses, they are counted like higher. They are for newer devices, and any, lower MAC address or lower number is older switches, older devices. So the lowest one wins, meaning the oldest one wins. The one who was manufactured first wins. And sometimes that's not good, because I don't want this old device to be the head honcho. Sometimes I need something new, something fast, or maybe something in the middle. Maybe it's not that new because we're still trying to figure out, how this device works. Maybe something that's been out for a couple years, that, is reputable, that's good for, build our traffic is strong enough. That's who we want to be the root bridge, not just because, you've been manufactured first. Like, you're old news, you're probably end of life, you're probably end of sale, and that's usually what happens. So a lot of folks will come in, especially CEOs, and will come in with a old switch and say, hey, my network's been slow, so I brought in a switch from home and I'm plugging it in with the Ethernet cable to my computer so I can have fast internet. And yes, that is logically a good troubleshooting step to do, but you're in an enterprise environment. You do that at home, you don't do that here. So take that switch out and we can do some things behind the scenes. We can troubleshoot why your data is slow, but you're just not gonna hook up switches to the network. You know why? Because spanning tree is gonna go haywire. And we're like, dang, what's going on? And that's because, whatever. So a little tip there is, the oldest MAC address usually wins the lowest bridge ID. So keep that in mind. So you might want to change the bridge ID. You might want to change the priority if you have some older switches in your lineup to say, hey, we don't want you to win. We want someone else to win. Okay, let's talk about BPDU, Bridge Protocol Data Units. BPDU, right, is the information exchange between switches to select the root bridge. So while they're going and communicating, it's not even really just to select the root bridge. It's how they communicate, period. They're going to communicate, period, by sending BPDUs, right? Bridge Protocol Data Units. And it's just saying, hey, what's going on? This is what we got happening. They're just communicating with each other. Okay. And it says Cisco switches send BPDUs every 2 seconds by default. The value can be configured from 1 second to 10 seconds. So, you want to get fancy, you can, change how many times they send out these quote unquote hello messages. Okay. So just know, how do they elect? So they have their bridge ID. All the switches are identified. Now, once they identify a leader, and they're talking amongst each other. How do they talk? They're sending BPDUs to talk amongst each other, because no one's sending data to them. No one is saying, hey, switch this data around, because that's all they know how to do is switch stuff, forward stuff. So if they're talking on their own, how do they do that? As far as in this protocol, they're going to talk in BPDUs, right? Bridge protocol. Now you can go in and learn like the actual like frame of the BPDU, but we're not going to do all that because that's not on the exam. Now we have the root port. Each switch has to have a path to the root bridge if it's not directly connected. Okay, so if it's not directly connected to that leader, it has to have a root port. It has to have a way to talk to that root leader if it's not directly connected. Okay, root port is the directly connected link or the fastest link to the root bridge from a non-root bridge. Okay, so root port again just means that this is the fastest way to get to the destination. That's all it's saying. So when the switch reads root port, and when we read root port, that means that port is open because it is the fastest and most efficient way to get to the destination, right? So each switch has to have at least one if it's not already connected to the bridge. If it's connected to the leader, then clearly it don't need a root port because it's connected to the leader. Like, duh, this is the fastest link. I don't have to specify it's a root, okay? Now we have another term, port cost. Each port has a cost that is determined by the bandwidth of the link, right? Port cost determines which of the redundant links will not be blocked. So how do they know which port to select as the fastest port, as the most effective, efficient port to send data? How do they know that? By port cost. Right.
Will be number 1 is TSU Team Hub. This is where all our hub information is at. This is where you'll go first, and you can ask questions here, create you a nice card with your name on it, and let us know what you're here, what your goals is, so we can help you accomplish that. Okay? The second board you would come up to is how to get a 6-figure job. This is my exact path on how I was able to break into tech and get a 6-figure tech job. Even when you got that job, or let's just say you are at a comfortable job, it may not be 6 figures, maybe, 90K, 80K, something in that sort, and now you're looking into making 6 figures in your business. You can use this board as well, so we can help you get to that goal with getting 6 figures in your business, okay, by utilizing technology. And the third one here that everyone mostly is at is the CCNA or Net Plus exam notes. All right. These are all the exam notes here. And we have it in our boards that you see where it has start, and you see our network fundamentals, network.
There's a cost. There's an STP cost and bandwidth. Okay. That's how we're determining cost and bandwidth. So if it's less, then it's going to cost more. If it's less speed, if it's slower, it's going to cost more, right? If it's fast, it's going to cost less. So if my link, here we go right here. I wasn't even looking at this. Here's the link here. I mean a little chart here. So if it's 10 gigabits per second, it's only going to cost me 2. Therefore, if I was to have something that was 4 megabits per second costing 250, which one would I use if I'm using the fastest and least cost? I will use 10 gigabits, right? And again, this is for spanning tree to do. And again, if you want, you can change these speeds up. Or if you feel like, well, why is it in 10 megabits? Why don't y'all up it to, 100 megabits? Can we get a 1 gig? And then, in the network, they're probably like, well, you know what? They may help our network. That may help with the CEO accessing websites faster if we upgrade from 10 megabits speed to 1 gigabit speed. So let me go here. Sorry guys, my mouse died or something. I don't know what's going on. Okay, there we go. So yeah, so it's the speed. Okay, the port cost. The lower the cost, the better it is. This is going to be on the exam for sure. Port cost. Okay. And I think it's more going to be so on, if you look at it like here, maybe, no, I should have a better diagram. Do we have some costs? Okay, boom, here we go. Oh yeah, port costs. I should probably just go from here. So, yeah, so port costs, as you can see, 1 gigabit, 100 megabits. Clearly, this is the fastest. These are, 2 fast links. This is not a fast link. So that's why they created this to be the root bridge, because has 2 fast links on the end. This definitely ain't going to be a root bridge, because look at this link, costs way too much. That costs way too much. And then this one is only 1. So obviously this wins the race, right? So once it wins the race, and it looks at its link speeds, then it could determine who's in forwarding state, who's designated, who's root, who's in block state. And what's so great? I can show you guys really quick. Let me see. Let me come up here. Let's do where we at? Networking equipment. Let's go to switches. So we got a switch here, a switch here, a switch here. Let's just do 3. And then we're gonna connect. What we connecting? Like devices. So what we gonna get? A crossover cable. Now look, you see the spanning tree is going on. That's why they're orange. They're figuring out who's the root bridge, what ports is going to be the root port. That's what they're figuring out. That's why these are orange, because they're communicating. They're sending BPDUs to each other. And then they're going to start electing. You're going to start seeing it turn green. That means that somebody got elected. Boom. Those must be somebody right here. It must be the root. Then these are elected. Now these must be like blocking and designated. Oh, yeah, that must be like a block port or something. So that's pretty cool. You can see it in real time like this. You can even speed it up. You see time? You can just speed that puppy up. And oh, this gonna stay blocked because again, it's going through spanning tree. So we know since this blocked, 9 times out of 10, this is probably the root. Let's see if it's the root. How can we tell it's the root? Enable. How can we tell? Let's go to switch 6. Let's go to our commands. Bridge. Maybe we can see which one is the bridge ID. If we do show spanning tree bridge.
It says tree root.
Oh, tree root. Where? Oh, spanning tree root. Oh, I definitely can do root. These some good commands, I guess. Yeah. Okay, show spanning tree root. Let's try that. Show spanning tree root. No. Let's see, show spanning tree. Let's do question mark. Show interface or active, detail. I don't want all that information. Status, summary report. Let's do summary. Summary sounds good. Okay, no, summary don't sound good. Oh, hold on, let me see. Bridge switch is in PVST mode. It's disabled. Nope, it's not saying anything. Root bridge for default. It just says default. Let's do active. Maybe that'll show me. There we go. Active. Show spanning tree active will show you what's going on. And you can see here, it says this bridge is the root. I knew it was the root because down there, that wasn't finna happen with that orange little dot. That means that it's not the fastest. So this can't be it. And this connected to it, so that can't be it. You know, that's an educated guess, but I got that right. Now you can say it tells you which one is the root. This bridge is the root. And you can use CBD, CDP, and LODP to discover all these switches that's connected to each other, right? Let me just show y'all. I know that's kind of like left field, but whatever. Show CDP. Sending CB packets every 60 seconds, sending a hold time value, the advertisements as enabled. So show CBD, maybe neighbor. I think that's what I want. Yes, neighbor. Neighbors. Yeah, so you show the neighbors. I don't really know how to spell, so I gotta be looking at this because you see it gets all type of crazy. And boom. So look, it shows what this switch is connected to, where, what's going on, what's happening. So that's how you do CBD, CDP. And that's how you see which one is the root bridge. Going back to spanning tree. Spanning tree active, show spanning dash tree active, and you can see the root bridge. Okay, so just moving on. Again, spanning tree, we're just selecting who's the leader and what's the fastest way we can send this data to the leader so the leader can send it out as fast as possible, right? And how they make the decision is they already have the lowest bridge ID. So oldest one wins unless you change the bridge ID and make it to, the lower one. Once they become the bridge ID, then we're going to go ahead, we select the leader, the root bridge, then we're going to go ahead and select the ports off of cost. And the root port is the ports with the quickest way, right? The quickest way. This is the quickest way. Any data obviously does not connect it here, so it has to be the quickest way. Right here, which one is the quickest way to send data? Up this one, right? This so right here, there's nothing connected, only one thing. So of course, the only interface is going to be the quickest. This don't have root ports. Why? Because it is the root bridge. There is no fastest way to it. This is it. I am it. That's all that is. Okay. So let's move it on. Okay. Oh, that was actually all the terms you really had to pay attention to. Oh, designated port. We didn't talk about designated port. The bridges on the network segment collectively determine which bridge has the least cost path. So if it's not the root port, then it's designated, right? And then after designated, like the really bad ones are just blocked. Okay, they're just like, you don't need to send data because you're gonna cost us way too much. So after they select port, everything else is designated. That's really how you can think of that. So that is the terms to help you understand spanning tree and how it comes together, which I kind of already said it high level. But continuing on, so switches, let me come here. Okay, so switches running spanning tree can be in one of 5 states: blocked, listening, learning, forwarding, disabled. Okay, so they kind of are what they are, right? Blocked, that means nothing's going through. Listening, that means the switch is listening for frames, but it doesn't do anything, it's just listening. Learning, the frame starts to learn the MAC address, right? Forwarding, once it learns the MAC address, the forwarding, it can now says, okay, well, here's where we can, switch the traffic, forward the traffic. And then disabled, obviously the port will receive the hello packets, the BPDUs, but it will not forward anything. It'll just receive it and it'll just be like a dead end because it's disabled, right? So what I showed you here, let me just do this and let me do that here. Okay, so when I showed you guys this right here and it was all orange and it was wonder and it was doing what it was doing, it was going through these stages, right? They all start off that block. They all start off that orange, like what's happening? Now they went from block to listening. So it took them 20 seconds to be like, okay, so now we're not blocked. Let's listen to the BPDUs. What's going on? Now, what are they? They're listening for the frames, but they're not acting on them. They're just listening to see, okay, who is the root? What's going on? Where should I send this data? Who's the head? Who's in charge? Where am I? Am I blocked? Am I not? That's what they're doing. And then after 20 seconds, they go from listening to learning for 15 seconds. So while they're listening, then they be like, okay, now let me learn these MAC addresses. I'm connected to here, I'm connected to there. Let me put in I'm the root. Let me put in I'm not the root. Whatever the case may be, they're now learning and becoming their identity. Now, after 15 seconds, they go from learning to forwarding. That takes 15 seconds. So now that they learned who their identity is and who their role is on the network, they now can forward traffic. Okay. Now, if any of these ports is disabled, if there's some type of failure, then it will go into a disabled mode. So there's no failure, it's just blocked right here. And these are, again, just letting you know what's happening, that they are ready to forward traffic. That's why they are green. Okay. So when you first connect the network, when you first connect these switches and the computer to the switches and do all this, actually, you don't got to go through all that. When you first pull up your computer and you connect to the network so you can get on google.com, the network is going through this right here. Your LAN is going through this. Okay. So that's about 50 seconds to start switching data. 50 seconds before you can actually get on the internet, before you can even send data to someone in your network, in your local network. 50 seconds on an L2 network, right? And down here it says it's known as conversions time. Okay. So that's what's happening. The network is seeing what's going on for 50 seconds before you can start doing anything. Now, for a enterprise company, that's way too long. There was Walmart, Amazon, a hospital. That is way too long. That's like 50 years. So we need something to speed that puppet up. Okay. And we do have something to speed that puppy up. It's called, let me go down here. It's called, we just skipped a little bit, but we'll go back. But we have rapid spanning tree, right? Rapid spanning tree is the same thing. It just speeds up this puppy, okay? And we can even have even more fast capabilities. Now, rapid spanning tree is RSTP, okay? And it's 802.1W. You might want to definitely know the difference, okay? Because it's going to say spanning tree. No one uses spanning tree because it's 50 seconds before we can even start switching traffic. And that's just ridiculous. That's way too long. We're going to lose our minds. So another protocol came up called rapid spanning tree, right? So now we do it faster. And they, let me see, what do they add? They add, instead of disabled, they keep on going. What rapid spanning tree got going on? Let me see the actual difference. Okay. So they just added more features. We shouldn't have skipped, but it's okay. They just added more features. PortFast, uplink fast, and backbone fast. They were new features to add it to spanning tree. So of course, spanning tree got a new name called rapid spanning tree. Okay. And these features help spanning tree become what? Rapido. Okay. And we'll get into them, but just know that yes, spanning tree takes way too long. So no one uses it. We use rapid spanning tree. So outside of rapid spanning tree, we have per PVST, per VLAN spanning tree plus, or per VLAN rapid spanning tree. Okay. Now these are a lot. They got a lot going on with spanning tree, but right now we really only use PVST plus, maybe PVST. We're not really using spanning tree. Like I said, that's 50 seconds. We can't handle that. Rapid spanning tree, maybe that saved about 10, maybe even 20 seconds, but we still can't handle that. So now we have a spanning tree that's a per VLAN instance. So because VLANs came out, so spanning tree obviously was like, okay, well, if I can do this within LANs, what about VLANs? What if you're separating multiple VLANs, and how does that happen? Now who's become the root bridge, and who gets the root ports and designate, like now what happens? So they had to come out with something called PVST plus and PVRST, which is just upgrades from the old school ones, which they still provide the same standard, right? So 802.1D is spanning tree and per VLAN spanning tree plus. 802.1W is rapid spanning tree or per VLAN rapid spanning tree. Okay. Now, again, they're just spanning tree instances in a VLAN in each VLAN. Okay. So it's the same logic that happens. So you understand spanning tree, right? We can understand that they have to elect a leader, and that leader is where all the data is going to transmit the fastest. So every switch on the network needs to switch forward data based on the root bridge's perspective. Okay. So everyone, all the switches on the network have a root port and designated ports. How do they determine these root ports, these designated ports, the root bridge? Through port cost and bridge ID. Lowest bridge ID win, lowest cost wins, right? We're all about the low. Okay. And they go through these stages as they're going through spanning tree, as they're figuring out who's who, they're going through these stages. Blocked, listening, learning, forwarding, and then disabled if there's an error. Okay, now we can start moving along in the network, sending traffic. Okay, that's spanning tree. That's really all spanning tree is. And there's different versions. There's a rapid spanning tree because 50 seconds is too long. And then we have a per VLAN spanning tree because now VLANs were introduced. So now we have to have a spanning tree for virtual LANs. Okay, the biggest thing is make sure you understand the standards 802.1D, 802.1W. Okay. W is rapid. D is the irregular. It's the original. Let's see what we can go in here. Okay, so they do all this, 50 seconds, take too long. STP is to be considered converged after 3 steps have taken place. So STP is done. All, the process has been converged after these 3 things. It elects a root bridge, elects root ports, elects designated ports, right? Now I went in here to give you a little more information of how they elect the root bridge specifically, right? The bridge with the lowest bridge ID becomes the root bridge. The bid consists of 2 values in an 8-bit field. The bridge priority is, 32768 by default, makes up 2 bytes, and the MAC address of the back plane or supervisor module, depending on the model of switch, makes up the rest of the 6 bytes. Again, that's informational. You need to know that what is the bid? The bid is bridge ID and MAC address. It wouldn't help you to know that the bridge priority and the MAC address. It wouldn't, kill you to know that it's 2 bytes, 6 bytes for MAC address on the switch. But honestly, if you don't remember it, that's not going to kill you. I doubt that will be a question. It probably encompassed in a question, but they probably won't ask you what the bytes are. That's so ridiculous. But it's good to know because it kind of makes you good for if anything happens and for interview questions, right? You can kind of feel a little smart, that certain things. Remember, when you're taking interviews, whether you're doing them now or when you're finished with the course, or as you go through the course, just always talk about what you do know. Highlight your strengths, not your weaknesses, right? And always learn how to segue into things. Like they may talk about something you have no idea, but try to segue into something that correlates and be like, well, I do know about, because that lets them know that, okay, you do have knowledge and you might not have answered my question, but I like the way you talk about the technology. Therefore, it's easy for you to Google something, right? They want to know that you can find the answer. You're not a dummy, right? And the only way to prove that is to, be able to segue into something that makes sense to the topic at hand, right? So regardless, boom. We talked about BPDUs, and then to select the root ports for non-root bridges will be only 1 root port. We talked about that. And then select designated ports. If a switch has redundant ports connecting in the LAN segment, downstream hub, for example, then the port with the lowest cost. See, we already talked about cost. So that's really it in a nutshell. Additions to STP, like I said, STP keeps the network loop free, but it takes 50 seconds. So for almost 1 minute, data cannot flow. For some businesses and networks, that's unacceptable. So to deal with this issue, Cisco added features to STP like PortFast, BPDU guard, BPDU filter, uplink fast, and backbone fast. These are terms you should know for exam purposes as well. PortFast is something you're actually going to do in the field, and probably the most important one to actually remember if you can't get them all in your head. PortFast, this one needs to be number one. Why? Because when you configure PortFast, STP will be disabled on those ports and will transition to forwarding state and will never be blocked. Okay, so you put in PortFast. Once you enable PortFast on that interface that's connected to that host, to the end device, 20 seconds is knocked off, right? 20 seconds off that 50. So now you got 30 seconds. That's pretty fast. That's faster, right? That's a little fast. So PortFast is something you always gonna use. You know, if you connect a PC or server to a switch port, it will not listen to BPDUs because it is not an L2 device, and create loops because it has a single link to the L2 network. Therefore, you can safely disable STP enabled on those ports. So again, PortFast means you only enable it on ports that's connected to an end device. Because what PortFast is saying is, this is not an L2 device. You don't even have to listen to any type of BPDUs. You don't have to worry about none of that because that's not going to send it. This device is just to solely connect to the network, to access the network, right? So as long as you can connect like an end device to that port, then you can put in PortFast. You wouldn't put in PortFast on a network like these three switches. Why? Because they need to listen to each other to figure out who's who, right? They're not an end device. So this is going to be something that you're definitely going to use in the field. BPDU guard, maybe, I don't know, I haven't used these, but it's good to know for exam purposes, right? On a PortFast port, if a BPDU is received, it will put the port into an error disable mode. Okay, BPDU filter on a PortFast port. If a BPDU is received, the port will lose the PortFast status and force the port to participate in STP. So STP. So filter guard, you choose which one is best, you know. It depends on what you're connecting to what. Okay. So again, these are additional features that you would configure to make it faster. And again, unless you are starting this network, most of the time you're just managing it. And you know, you're really good at knowing this information. You can actually come into a network and be like, y'all don't even have PortFast on the ports connected to the end devices. That's probably why your network's slow. So let's enable PortFast. And they'd be like, oh, really? You know, or they'd be like, well, we did have that, but you know, and then you look good because you just called out something so elementary that they missed out because they have 20 years of experience. Like, you know, so much with guard and filter, the same thing. Like, you may not be the one that's actually architecting this from the ground up, but you can definitely look into their configurations and be like, hey, something seems a little fishy here. And they appreciate that and they'll love you for that. And then you could be like, hey, actually, you should give me, you know, some more money because I'm out here helping y'all. And boom. And then we have uplink fast, help speed up the convergence in STP. And then we have backbone fast, works on finding an alternative path when an indirect link to the root port goes down. Okay, they kind of sound like what they do. Backbone there for support, case something don't hold. Uplink, right? A little faster if you're, you know, speeding up the links. Filter, we're filtering out these BPDUs. Guard, we're gonna say, hey, if something happens, we're gonna guard it and put it in error disable mode if something breaches it. PortFast, we're gonna fast up this port. Like, these things are pretty self-explanatory if you ask me, you know. So yeah, with all these new features added on the spanning tree, we get now the rapid spanning tree. Okay. And yeah, and then of course it breaks down to even per VLAN spanning tree because not only do we need to be rapid, we need to have it in different VLANs. And remember that PVST plus and PVRST per VLAN spanning trees both add the VLAN number to the bridge ID. So in the per VLAN instance of spanning tree, they add the VLAN number to the bridge ID of every switch. Okay. So that's a good thing to remember too. They may ask you something like this, something in a combination. And then configurations. Again, you're not configuring anything. You're literally just verifying. You can probably configure, like you can change a priority, right? We can change a VLAN. We can put it in different modes. But honestly, you're just verifying. Okay. Because we don't configure spanning tree. Like I said, this is something that's pre-configured on these Cisco switches, on switches, period. Not even Cisco, because it's an open standard. So it just happens how it happens. So we just here to know that it happens and know why it happens. Okay, just knowledge base. It says, let me see, tip, each switch gets one root port. The root port has a designated port across from it, and the rest are blocking according to highest number. Oh, each port. So these are some notes I took. That's pretty nice. Because these are honestly my notes from when I took the exam. You know, this is exactly what I studied. And I just turned these into flashcards and just, you know, studied them. You know, I got this from the book and I was YouTubing a whole bunch of folks. And the book is really helpful too. I read some of the book. And the book was it was online, the ebook. And this is where I got all this from, right? So you can read the chapter if you want. It's up to you. It's a whole bunch of stuff. But honestly, you just need to know where we at. You just need to describe the need for rapid spanning tree protocol and identify basic operations. Rapid per VLAN spanning tree plus. What is this here? That's I don't know what that means. Describe the need for and basic operations. Okay, describe, I wasn't even reading right. And the basic operations of rapid per VLAN spanning tree plus, and identify the basic operations. So, you know, why do we need it? We need it to keep L2 network loop free. This is the standard, okay? And these are the terms that associate with it. So when you say identify basic operations, anytime you see BPDU, you should be like, oh, that's some spanning tree stuff. That's some spanning tree message. When you see root port, designated port, and how they become root port and designated port, oh, the cost of the port, it's about speeds. You know, the faster the speed, the lower the cost. So, you know, if you are not technical at all, you've never, you know, had anything, no technical, nothing, then, you know, you probably would want to brush up on your like megabits per second and gigabits. Know that gigabits are more than megabits, right? So definitely know at least that. So when you see megabits and then you see gigabits, you kind of know which one is, you know, slower and which one is faster. And you can kind of know that already. You don't even have to really be technical. Like your phone, don't you want your phone to be in 5G? You know, so what is that? Fast speed. So if something is not 5G, under 5G, you're gonna be like, well, that's not fast. Use the same logic. Use the same logic. All right. Use the same logic. 10 gigabits. Oh, 10G. Oh, that must be fast. All right. Don't make it hard, y'all. This is really good. This little table. Oh, this table is really good. The 5 states. It's disabled. It's blocking. Is it receiving PBDs? Is it sending? Is it learning the MAC address? Is it forwarding data? Like, this is so freaking good. And then, this one, you see root port, designated port, root. Okay. And in my notes, it says something like a root port. Each switch gets one root port. The root port has a designated port across from it, and the rest are blocking. Each route has a designated. Each route has a designated. And it's a block. Because some gotta be blocked because we can't just, something, we gotta redundant links. We gotta, keep the network loop free. So somebody gotta be blocked. So you see, that was a nice little tip. Y'all should write that tip down. They may ask you that on the exam. That's probably why I wrote that down. But yeah. And then we have here, I should have just went through this. This was very more visually pleasing. Lowest bridge ID becomes a root bridge. Bridge ID equals priority of MAC. I'm gonna start going through these first because clearly they're more visually pleasing. And then elect a root bridge. See, this really gives you the downplay. So, you guys shouldn't be too confused, all right? And then a nice little rapid spanning tree takes 21 seconds. Regular spanning tree takes 50 seconds. Way too much. We do not like that, okay? We do not like that. That is not what we like. And then the characteristics of what's going on, MSTP, I don't know what that's got going on, but the rapid, that's Cisco. The rapid per VLAN spanning tree is Cisco. Okay, so Cisco, the one that only uses per VLAN. Everyone else uses either spanning tree or rapid spanning tree. This whole per VLAN stuff is Cisco, which makes sense because Cisco really like to do their own thing. So resources needed, convergence, fast, this is all fast. Tree calculations, all VLANs, per VLANs. Obviously, we know that per VLAN because it says VLAN per VLAN right here. So this is good to know, right? And then let's see. Root port, root bridge, primary, secondary, and other port names. So you already know that port states and PortFast benefits.